which one are open. So all of them. So you didn't have to list all lockers. That's okay. For the second question then, which lockers remain open after the second student?
You muted yourself, I think.
Oh yeah, Mr. Collins, you're on mute.
I know, yeah. That's okay. Thank you. Sorry, there was a teacher in here. Which lockers remain open after the second student?
Are we supposed to come into chat or?
You don't have to tell me when I'm on and off mute. I am aware when I'm on and off mute. Thank you, Chris. All right, which lockers remain open? So a lot of people got this answer right. So at the second student pass, every even locker number was closed. So all the odd numbers are open. Yes, so correct. So I think nearly everybody got that right. Okay. Next question. Which lockers remain open after the fifth student? So you have to do some process. I'll show you what my process looked like. I just used color codes to do it. And I had these numbers. So it was a matter of whatever way, open, closed, open, all that kind of stuff. And hopefully you recognize that the third person would touch every third locker, 3, 6, 9. The fourth person then did every fourth locker, 4, 8, 12. Okay, Charlize. All right. So you should get these answers. I think all groups got those answers, or maybe one of those was off. Now, this table then needed to be complete. Now, I told you when you were in class to do the fifth one next. And the answer to the fifth one was 1, 4, 9, 16, and 25. That was the answer. After 30 students have passed. Now, this process, if you did it the long way, this process would have been a lot quicker had you just, after you get past maybe 6 or 7 people interacting, because they're not really interacting with a lot of lockers. Like the 10th person only interacts with 3 lockers, the 11th person only interacts with 2 lockers, and so on. And once you get to the 15th person, of course, everywhere from then on only interacts with 1 locker. And that's linked in slightly to the number of factors. So if you filled out this table, and I'll put in my filling out while I printed it out. I filled in this table, and we are looking at these are the answers of the factors. So for instance, 28 has 6 factors. I think it's not focusing, but it's focused now. 28 has 6 factors. 1 times 28, 2 times 14, and of course 4 times 7. And that means, well, we can translate that to this problem, because the first person, the second person, the fourth person, the 7th person, and the 14th and the 28th person interacts with the 28th locker. And therefore, if it's interacted with an even number of times, an even number of factors, it would be, well, would it be open or closed? If it's even versus odd. And that was the key to this number of factors. And that was the key to this. And that was what question. So to fill out this table, I'll fill it out really quickly now and make sure you can double check with the right answers. 2, 4, 2, 4, 3, 4, 2, 6, 2, 4, 4, 5, 2, 6, 2, 6. Oh, here we go. 4, 4, 2, 8, 3, 4, 4, 6, 2, 8. Okay, so I have it filled out now. Okay, and that was question 4 complete. Now, question 6 asks to explain how you determine that these particular lockers are open. So that was these lockers in question 5. What do you notice about the open locker numbers? And what do you notice about the number of factors? So I'm looking at these open locker numbers. That's locker number 1, 4, 16, 9, I forgot 9, and 25. What did I notice about the number of factors? What did anyone notice?
They're all odd.
Odd, yes. Odd number factors. 1 has 1 factor, 4 has 3 factors, 9 has 3 factors.
They're all squared numbers.
And they're all square
Plus
numbers.
one.
That's
Yeah,
the reason.
All of
Oh, wait,
them
Yeah.
one-
no, one's good,
square.
yeah.
Yeah, you all have it.
I don't really-
That's the reason why they are. Sorry, another teacher. Okay, so yes. So we noticed that they had odd number of factors. Odd number of factors. Now, okay, Pauline and Julie, you could have literally continued on this process of open, closed, open, closed, open, closed, and you would eventually get your answers at 1, where's my answers? 1, 4, 9, 16, 25, if you did it perfectly. Now, the crucial thing here is that these are square numbers. In other words, 4 has an odd number of factors because its factors are 1, 2, and 4. And because 2 times 2 is 4, it's 1 times 4 and 2 times 2. But 2 is only counted once. And because it's touched 3, that is 3 times. The same happens for 9 because 3 times 3. 16 for 4 times 4. And 25 for 5 times 5. So maybe at some stage you're getting that aha moment here. The second person doesn't touch it twice. He only touches it once, although that factor is counted twice, if you think about it. So perhaps that is an aha moment. But we know that if it's touched an odd number of times versus an even number of times, an odd number of times means that it is open. And an even number of times means it is closed. So if the first person opened them all, and then if they're touched 2 times, they'd be closed, wouldn't it? So that's all the prime numbers. And I think that's what happens here. Touched exactly twice. Well, the first person's opened them all. If you think about it, like a number like 19 only gets touched once and on the 19th time because it's prime. So how many lockers and which one are touched exactly twice? Well, I can write these. Exactly twice are all the prime numbers. So prime numbers 2, 3,
Two gets
5.
more than
7.
twice, I think.
Sorry?
Two gets touched more than twice. Oh, no, it only.
No. 11, 13, 17, 19. This is tested my prime number ability. 23, without turning back to 29. We're all touched twice because they're all prime numbers. The first person touches them, and only the other number, the 11th person for the 11. No other number would touch them. So it's all based off factors. So I noticed that they were all prime numbers because they had 2 factors. Which students touched lockers 24 and 30? Okay, how do I know that? Well, Lewis, question.
Yeah, so for number 7, 9 lockers were touched, right?
9 lockers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
Should be 10, I think. 10 of them were touched twice. So they would have 2 factors. Which students touched both lockers 24 and 30? Well, that's about the factors of 24 and 30, if we think about that. Because the first person, 1 is a factor of these, 2 is a factor of both these. They both touch them because it divides in evenly. 3 is a factor of both these. 4, is it a factor of both? I think it is. So does it divide in evenly?
No, 4 doesn't.
4 doesn't. Does it not? Oh.
No, 30's not.
Oh, it doesn't. Sorry, not into 30. No, 5 does though. 5 doesn't do this one. Yeah, you're right. 6 here. 6 here. 8 here, not 8 here. 12 here and 24 here. Finish that one off. 30 has, if I'm missing one, 3 times 10, 2 times 15, and 30. Okay, so I've listed all the factors here. So which students touched both 24 and 30? 1, 2, 6. Oh, 3. Sorry. 1, 2, 3, 6. They both touched. So that's the reason. Which lockers switched the most times? How do you know? Well, that would be the one with the most factors. The one with the most times someone touched it is the most factors. So I go back to my list of factors. That's harder to see in that. Where's my other one? Oh, it's easier to see on this one. Which of my list of factors? 30 has 8 factors, 24 has 8 factors, and everything else is touched less than that. So the answer to this one is 24 and 30. So these there, and how do I know? Both have 8 factors. So that means they were touched 8 times. Last question. If there were 100 students on lockers, which lockers remain open after the 100th student has passed? Well, you could draw out the diagram, but perhaps that would take a while. Draw out the diagram of 100 lockers like this. But I think that would take too long. So we need to formulate a pattern. Now, my initial numbers are 1, 4, 9, 16, 25. Now, does anyone have what the next number would be in this? Now, a couple of people did get it.
The next number would be 36.
Why?
Because it's the next perfect square up to 100.
It's what?
It's the next perfect square to 100 after 25.
It's the next, yeah. So the reason this had odd number of factors because 1 times 1, you only counted one of these, 1. This was 2 times 2. This is 3 times 3. This is 4 times 4. This is 5 times 5. So what I'm developing here is a pattern. The next one would have to be then 6 times 6, 36. The next one then 7 times 7, 49. The next one 8 times 8, 64. I'm skipping one. Next one 81, 9 times 9. And so we essentially created a formula. The first answer was 1 times 1, 2 times 2. So I can actually create a little formula here. Watch this. Y is equal to x times x, where x is the person passing, and x times x is x squared. Now that was unnecessary, but I've created a little formula. Y is equal to x squared. A bit of algebra, which is the next unit we're moving on to. Okay, this is unnecessary because I just know the numbers. Now, what are we doing today? So this was well answered by a number of groups. I will commend a couple of groups here. I do remember, I think the group with Rani in it did really well. Was it Asia, Lauren, and Akim? You guys did really well. I think you pretty much nailed most of them. And Julie, yeah, question?
It's Pauline.
Oh, Pauline, yeah.
For the 30th student, I thought there isn't. Is the quickest method connected to this method? Or do you just have to do it a long way?
Is this method connected to finding the 30th student?
Yeah.
Yeah.
So do you just need to do it the long way for the 5th question?
For the 5th question, you could have done it the long way, or you could have done this way.
But how do you do it this way for the 5th question?
Just stop here, because after this is the 36th person.
Yeah, but how do you know how to stop there?
How do I know?
5.
Another way
This is when 25 people have passed. 25, that refers to the 25th person, 25th locker. Sorry, not many people passed. That's the 25th locker.
Another easy way, can I share another easy way that I found to get the to get which ones were open and which ones were closed.
Sure.
Might help make it quicker for other students. So what I did was I laid out the numbers as were in the diagram, and like for each student that passed it, I put a dot on, and whichever had an even amount of dots were open, and whichever had an odd amount of dots were closed, or the other way around.
And that's about factors then, isn't it? So
Yeah.
yeah, exact same. Yeah, so that's another great method. Yeah. So the reason I stopped here, because this 36 would refer to the 36th locker. So I don't need to go any further. The idea is that when I referred back to this table, I have just picked out the ones with odd interactions. The number of factors is the number of times it's touched. So for instance, the first locker clearly is only touched once, the first person. After that, no one else touches it. The third locker, or the fourth locker is only touched 3 times. The first, the second person, and the fourth person. After that, no one touches it. So the reason this table is applicable is because it tells me the amount of times it's been touched based off the number of factors. Okay. So this is just about pattern recognition and just thinking about patterns in a different way perhaps than maybe you're used to. Any final questions on this? Julie, is your hand still up? Or Pauline, is your hand still up? Or
Oh, no, sorry, I forgot.
Okay. All right. So what we're getting on to today, we're going to go back into our breakout rooms, and I'm going to, you never need to ask to go to the bathroom. Just stay on the line. It's fine. I'm sure you'll be back. Okay. So I'm going to put you into breakout rooms now after I post on ManageBack. Okay, so we're going to do a little another algebra. This one's a bit easier, hopefully. What I want you to do is so it's broken up into parts. You'll see I've sent it through to you on ManageBack now. I'm going to present it on screen. I'm going to just hang up this phone. Okay, and I'm back on this screen. I'm just going to present my screen now so you can see what the investigation looks like. Okay, so this is our investigation, a little bit easier. It's just a sequence of triangles and squares. So you're going to be sent off into your group and you're going to be asked for the answers to part 1, okay? Describe any patterns you see, so just talk about, so once again, we'll have one scribe who will write their answers into their book. You just discuss and one scribe will do it. And question 2 then, when there's 6 triangles, how many squares are there? And draw a table. Can you draw a table to show the pattern of squares and triangles? And then there's a part 2, and that builds up a little bit like the last investigation. But all I want you to do is do part 1 for the moment. And when you have that done in your group, just send a picture through to me, and then I'll join that group. Whoever wants to send the picture can, and then I'll join that group to start you off in part 2. Yeah, that makes sense. That's already sent to you on messages in ManageBack. So I'm going to split you up into your groups now. I'm going to give you a time this time to have it finished. I'm going to give maximum 15. Okay. Okay. All right. So when you go into these rooms, someone volunteer to be scribe. Just write it in your book. Maybe someone with neat handwriting, and then discuss it amongst yourselves. Maybe someone can share the screen of the thing, and then when you have an answer, take a picture of it and send it through to me. Or you can do it online and just share at Google Doc with me. Either way.
Excuse me.
Yes, Rani.
So does just one person write it in their book, or do all people write it in their book?
No, one, just discuss, and one person either writes it in their book or does a Google Doc and shares it with me at the end of time. Okay?
Thank you.